Today's video is about these, commonly called an interconnect, but basically a bit of wire with plugs or sockets on the end. In particular, I want to talk about the connection of a preamp or similar piece of equipment to a power amplifier. The reason that the slide at the beginning of this video shows a picture of an IC and some wire and then a list of a few things that means it's not a very good idea to connect. When you consider many preamps and many DACs and numerous other pieces of equipment, the output is often connected by a 5532 or an LME, for example. Nothing wrong with these ICs, but it's how they're used is the problem. Most people would tend to think that if you spend copious amounts of money on a lead, it's going to sound better. Shock horror. A cable does not have a sound. It really doesn't. You can't measure any difference, and you certainly can't hear any difference. Whether it's a $6 cable like this, or whether it's a $200 from people with too much money, they will not sound any difference. But the difference that they can make is what it's connected to. Most of the parameters that people talk about in cables is the shielding and the internal resistance. Shielding won't make it sound any better or any worse. All it means is it's going to reduce the possibility of interference, RF interference, if you're next to a modem or something. That needs to be reasonably good, but it will not affect the sound. The resistance of the cable largely won't make any difference either, simply because it doesn't have a high enough resistance that it's going to make any appreciable difference. But the thing that's very rarely talked about is the capacitance that a cable has. That's what will make the interconnect appear to sound better or worse. For example, if you look at this slide, it shows you overshoot largely on this slide with a 10 picofarad load, and the second slide on the right hand side shows you 100 picofarad load. You can see the difference in overshoot, and on this particular square wave that's a relatively low frequency, you don't see much effect on slew rate or high frequency loss, but it's there. And this is from Texas Instruments that make the LME and most of the chips that one would use in the audio world. What this means, in fact, is if you use an IC like this as the last stage in your DAC, preamp, or whatever else you're connecting it to, it doesn't like a high capacitance load. Another thing that's mentioned in preamps is the fact that it doesn't like to see a very low impedance load, and these ICs typically say the load should be in excess of 600 ohms to get the performance as specified. Now, generally that is not a problem unless you're going to try and drive it with a very low impedance load, i.e. like headphones. Then the performance will degrade remarkably fast. Ironically, in this case, not because of capacitance, but because of resistance. You're trying to draw too much current from a device that isn't designed to feed much in the way of current. Now, there are various ways you fool the IC into thinking that it hasn't got a high capacitance load, and one of them is just to put a resistor in series with the output. And this is what's done on countless products. It sort of works, but then if you think what is on the first stage of a power amplifier, and that's usually an RF network to get rid of signals from transmitters or wireless or something like that. And guess what that's made of? Capacitors. They won't be 15 picofarad or something low like that. They could be 200, 300 picofarad. Clearly, if you were to add the capacitance of the lead that you're connecting it to, you could easily have 400 or 500 picofarad, which would give you all the effects I've talked about previously. As I said, but there is a cheat on that, and that is usually to put a series resistor in the output before it goes to the actual output sockets, and it's typically 68 to 100 ohms. But then you've still got capacitors on the end of that, and whilst you're not damaging, well, damaging is not the word, deteriorating the IC, what is a C and an R network? It's a filter. So you're fixing a problem with another problem, possibly less important, but there is another way round that, and that is the way that we've chosen to use on our preamp, which has just been discussed on the last couple of videos. Rather than take the output directly from the IC, we've got, if you like, a buffer stage in the form of 2 or 3 transistors. That has the effect of lowering the output impedance even more, to about 20 ohms in fact, which means you could run a pair of headphones, a very low impedance pair, directly from the output. And it also means that you never load the IC with capacitors. In fact, the only capacitance that the IC sees in such a circuit is the inherent capacitance in the junctions of the 2 power transistors. Well, power is not really the word, the 2 output transistors. You would expect that to be about 20 picofarad. If we've now got to the stage where the IC never sees anything less than a low output impedance and about 20 picofarad, in this little spreadsheet here I have put together 5 typical cables. The thing that's important is the very last graph that shows you picofarad per meter, based on the idea that 1 meter is the typical length. If you can make it shorter, even better, but if you make it longer, then you definitely need a preamp similar to ours. And I must say at this stage that other preamps that do the same thing also exists, but we're not talking about those, we're talking about ours. Anyway, you can see the custom-made RG59 has the lowest capacitance of any of the cables, and ironically this is one that Ron has made up. Here's the little meter I use, readily available from Ali and the usual mob eBay. I've just finished measuring a cable, and this particular one was 298 picofarad, and that's the one that I was holding previously. So what are the conclusions that you can draw from these simple tests? First of all, make your interconnect cable as short as possible. The second thing is, if you buy cables, obviously purchase the shortest one that will fit, and also take notice of its capacitance. If it's high, don't buy it. Do have cables that are relatively high capacitance. There is an answer, and that is to use a preamp like ours. Obviously I'm going to recommend ours, but there are others that have a transistorized output stage. The cables that tend to have the highest capacitance are ironically the ones that often have the smallest footprint, because the conductor is very close to the sheath on the outside. In other words, very little thickness of insulation, and the further, or I should say the closer the two cables are, the higher the capacitance will be showing. So ideally, if you could get a cable that thick, it would have very low capacitance. That's the end of this quick video. Thank you so much for watching.